Доброе утро. Ух ты, здорово. Какое грохочущее эхо. Мне было позволено вас сегодня разбудить. Мне будет просто, я буду говорить, а вам надо сидеть и не заснуть, это тяжелее. Значит, ага, он спит. Почему? Ага, все, разбудили.
Okay. So I'd like to talk about certain things and identify some thoughts. So let's start with a riddle. It's a magic number, 104. What do you think it? What do you think it means? What does it mean? 401. Yes, if you sweep it over. Okay, that's good. And this is the number of days that Google will allow to remove vulnerabilities from this software identification of vulnerabilities. Then this is the timeline, and then the developer has time to do a patch update, and the user can use it. And so this number actually speeds up other concomitant processes because, for example, a couple of years ago we had number of days to removal of the problems. And no one is happy with this number. So the users don't like it, the developers don't like it, because it's so fast and there's not enough time. So then the researchers don't like it, the developers don't like it. So being a researcher, so understand that 104 days is nothing. So very little time. So compared to the time it takes to develop a new software, and the regulator doesn't like it. So then the regulator isn't say that absolute security is replaced by risk security, comparative security, certain level of security. So they know that a certain will be hacked, but when? So it's just a matter of time. And so then the regulator is resigned to that the system will eventually be hacked. So then as I was saying, so then the developers are hacked, the regulators bite the bullet, and the researchers are unhappy about the timelines, and so then the situation is slowly changing. And so even those who who ask for services, so they're not happy with the results because usually so there is a red pillar, so this number of vulnerabilities goes down, but if you study the software, and then eventually the situation is levels off, and then you get the impression that the number is not changing. So what are you doing? So you invest a lot of money, it's very time-consuming, labor-intensive, but this figure is not improving. And this is kind of this roulette of hatred. So when each hates everyone else, each one. And so they hate each other. So both the regulator, the user, the researcher, the developer, and so then this hatred arrow turns around. And this is what. So then in the last 5 years, so we've been trying to figure it out. And so then we came from a company that certifies its products on the basis of paper requirements. And we realized that we need to do research on practical security, and even just also talk about the importance of regulators, because their paper regulations are very important too, and that's related to the practical security. So some say some reproach. There are some reproaches going around. So there are people wearing coats and tie, and so there are people wearing T-shirts. And so when we talk about vulnerability, so why the algorithm? So because there's the idea that has been formalized for information systems, and then eventually and contains certain things that were part of something written on paper or was in the head of a person who developed it. And I think that so these components should not be pitted against each other. So they need to complement each other, to be synergetic for the sake of the developers and all stakeholders and the regulators and the users too. And so that would comply with the requirements of the regulator. So let me say a few words about myself and what do we study and how it's been going on, and what mistakes we have made. And so I go back a long way concerning IT security. And so we are part of Infotech's group of companies, and so we've been that way over the last 5 years. So we work a lot. So Infotechs. So this is a very complicated crypto systems. These are the components. So we, for example, so we protect so the Russian Railways tickets. So then and other things. So we write the codes. We develop the software, and so it works pretty well. And actually, we perform pretty well. So about 5 years ago, and we got the impression that besides the functional requirements that should be compliant to the requirements of the regulator, we should have concerned ourselves. So the functional characteristics of the products. So we started with the efficiency. So then we were trying just to get to the gigabyte speed, and we were catching up so altogether because the world market went far ahead at that time. So we caught up with them and so developed new approaches how to complement so the testing methods, functional tests, auto tests, different tests, user experience tests, etc. And so we just increased our efficiency. So then we calculated the errors, etc. And the next step, logical step, so would be to concern ourselves with security of our solutions. And that was very important, and that was related to the fact that the publication about vulnerability started to seep into the pages of the mass media, and then so people were confused. So what to do with that? Because lots of vulnerabilities, security is not there. So then. And the people were confused. So it's certified, but at the same time it's vulnerable. So then there are patches, so they need to be used. Protection methods need to be implemented, and so this is how it evolved. And so the key points that we in 2012. So 2012. So now just so we're concerning ourselves with the issue of secure development. So that to embed security in the development process. And so then the monitoring centers. So this is what we are. We launched in 2014. Monitoring centers were launched. So we monitor. So we monitor the development effort of the developers of software, so to make it congenitally secure. And so what are we talking about? First, so the first idea, I don't want to talk about how we were hacking products, because I know that there are two factions. So some of them know better how to hack product than me, and some others are not interested how to hack products because they have their own people who know how to hack products. And so, but we, with the help of different methods, famous means, so we organized a certain effort how to increase security of the products. So this method. So I think that we found very important point, which allows to give more value from research and to justify it for business purposes and for the developers. And in process, sometimes we got good results, sometimes we got negative, positive experience, but any experience was welcome. And And then, so we just followed in a sustainable fashion, so that contributed to the cycle of security enhancement. And then we needed to understand better. So the developers of big systems with embedded security, so companies, so it's IT systems, business processes, like any other company. So then IT security issues are very pertinent. So the IT security is one of our core products, and people are excited. And our company has been participants of different important, so our Asian friends, so invited us to Russian conferences, so written in Russian with lots of grammar mistakes, and so they try to distribute viruses to insert those viruses into our IT system, and so this is the something that is high on the agenda. And so then so we have a lot of information, and the product that we develop, it's up and running. You can get a remote access to our product, and it's of great interest because it's certain knowledge for the people so who attack IT systems. So that's a complex product. So with a life cycle, which consists of a number of components. And so the product needs to be certified, and we came to the conclusion this is the product that requires so a certain deal of interest to IT security, starting from the development of requirements, certification, design, development, testing, all the way. So when you stop operating the system and when you remove it, discontinue. Yeah. And so all the way to the end of the life cycle. So when you destroy the system, and we decided to learn to see what kind of experience exists in the market. So what is the secure development of a product? And we started to apply what's written here to the extent we understood it. So, but if we look at different domains, so those are the stages of secure development, like monitoring and responding the vulnerabilities, and then the life cycle, then everything that has to do. So people, technology, business processes, all these components that put it together and make it go, all this stack. So we realized that we need to do it and to follow all these points. So if we start with, so we started with, many of my colleagues started with the following. As my colleagues were saying, so then the developing organizations, developers, researchers in the area of security issues. So we started with ourselves. So we did the audit of security audit of all our systems, because we are all around our country and we have offices abroad. A lot of information is stored within our systems, and if you streamline it, then theoretically, so you can think up a number of attacks, so that could be launched against us, so against the client, users of our system, against us, so then via us, etc. And so we look at everything we have. So this is quite interesting and juicy for bad guys, And so this is a technological company. So the developing center is distributed and quite big. That's what we have, and so many things add and go and change, are shuffled all the time. So all the resources are administered by the developer, and so then the programming engineer, so then his virtual machine, etc. So he's the ultimate authority. And the same is true of the support department, so they can outsource certain things and become more vulnerable. But when we talk about the security protection, so it means that we have to work with outside software, not in-house software, but compatibility tests are there as well. And so then the product is of great interest, and it can be, we haven't had it, but our colleagues have been instances when they try just to attack them, to hack them, and to steal the materials, the development materials. So quite interesting. So it means that the developer is an interesting target, very interesting target. So if you hear what the regulator says, so that's a good solution for hacking. So the hackers are very much interested. So the specialized target, attacks target, attempts to hack into the information system, that bespeaks the importance of our system and its wealth. And so, for example, we can get together our own WIPNet and then distribute it. So there was a similar story. So recently there was a publication that some companies distributed Trojan viruses for 3 years, and it was okay. So they were still successful, although they were distributing Trojan embedded software. And so then, by the results of the monitoring and the audit, so we decided it would be logical to set up our own monitoring center. So for our partners, for our companies, for our group of companies. And we do not claim that we created some new CM. No. What we need CM. So we need our own functionality and reliability. That's all we need. But as we go, so we need to develop more stuff by ourselves. And it's not only the analysis, collection, and data collection. So we can get a lot of information from the public domain sources. But what's important is to joint effort, ticketing, and synchronization with the client base and in-house, so with outside companies, following the tasks, identification of. So this is public software and is geared to the incidents and the life cycle of incidents. And so now I'm finished with general statements. Now, so what is this monitoring center doing? So besides the standard procedures, analysis of IT systems, monitoring the audit results, so then the vulnerabilities identification. So we saw that there were a lot of challenges, private challenges that are very important for the reliable development. So that would be the final story of success. So, for example, very popular, control of the publications of vulnerabilities in the third-party components. So very interesting thing, because there are hundreds of outside components and the OS, NOS, and there's some libraries for visualization. So they're third-party components. If you don't try to monitor those vulnerabilities which are inherent to those things, you can always compromise the product, final product, your product, because you identify it only after the event, after the certification has taken place, and they're very difficult to change anything. So, and the vulnerability explodes, and it's too late to take any steps, and too expensive. And then, so then mentionings of the products on the internet, what's good, what's bad, and so when we monitor the notations, mentionings. So, for example, VIPNet coordinator. So what's the point of selling VIPNet router through Avito? So unless they know what that is, so why should anyone want to buy it? And so then. So they start, so they become very popular. People are beginning to buy, although they don't need them. And then moving over to the technology, to the technological stack. So I'm not going just to list all the instruments and methodologies, procedures. I'm not going to do that because there's a long list, and very technical. So I don't want to go into it. Then we can just say that so there are some static analysis, economic analysis. We do the phasing, and we do what we get at the final stage, and for this we develop instruments. And so what I wanted to tell specifically is what's the final outcome? What's the outcome? The experience goes to prove that the testing department works very well. And although it has no competence on testing for security, but they do it anyway, so they adapt the auto tests that can do the reverse testing, and so make several runs on new versions, old mistakes, and to debug them. And so this is what we take it to the testing department, and it's done there. Then, as we progress, so we identified very interesting points. So what not to do, how not to research, and what needs not to be done, what you should not do. So when you analyze the product, so the software I'm going to talk about, and so then analytical effort. So when we say about white box testing, so you should read documentation, because if the hacker has no information, historic information, because the hackers always read all the manuals first, and the young guys and technicians, so they start immediately to phase in, to hack. And it turns out that they either just catch the problem in a different place, or the problem is not the problem, because this element will be used in a general system. But there is another extreme, and so they made many more mistakes. So when the researcher decides to expound his vision of the product, or their vision of the process, they rewrite the technical documentation, and it works out that they're not analytics, neither they are programming engineers, and no one knows who's going to use the results of this effort. And another dimensions of this problem is coordination with those who order this work, so commission them to do that, and so there are many participants, many stakeholders to the process, and so they are after different aspects. So there's the development manager, so they're responsible for one. So there's product manager, so process manager, so then they are responsible for other things, and so then magnetic fields, for example. So they're trying just to always so make sure that there are no magnetic storms anywhere. And so then the process engineers, and if you don't discuss it with all stakeholders, and if you don't have this team effort, if not all stakeholders are there in this team, so then there will be a lot of unhappy people and unhappy customers, and that might kill the project. What's this? Do you know what's this? What's this? I showed it on Web Developers Conference. No one knew what that was. Because what is that? It's true that the developers they use different instruments, and so that the researchers know about, and they use them in their own way. And if you go back a bit and look at IT with the eye of those who developed compilers OS. So they see differently, completely differently. So then, so the overflow of memory, etc. So, and this is where this is the end of information security. So because they're not interested in anything else. The same with the programmers. So they think that so what you do should not be done because it's somewhere tested, and so they use certain instruments. And if they say that everything is fine from the instrument point of view, so they're not concerned. And the same with the management. The same goes is true of the management. So the classical management, what is it supposed to do this? To do it timely manner, deadlines, meeting the budget, etc. So, and then so certain amount of and within the budget. But if, for example, so then if the security requirement is not there, so then any attempt or any desire just to make this gadget safe, so will fall on dead ears and on deaf ears. And that's why no one will be concerned about that if it's not part of the statement of work. And so there are no reasons to do this kind of work. And by the way, they say the same problem. So big companies are riddled with this problem as well. And certainly it exists in the developers community, although they understand the issue very well. I'm not going just to go into greater detail, but at every stage, so we have lots of materials we can learn from. And so we relied on the attacking methodology. It's in public domain, the lists and everything. No need to list them, but very important to apply them on the purpose basis, on the needs basis. So then the methodology, so when there are other types of methodology, best practices for systems, they're good for the systems, but in practice, so then the system consists of several components, for example, web applications, server, mobile platform, and certain type of cryptography scattered around. And then for this type of configuration, there is no so combined methodology. And then there are some gadgets and devices that are outside programming effort, and so they can be connected at a later stage. So there's this methodology, and so then a good application method. This methodology allows to develop methodology. That's very interesting. So the methodology that allows to guarantee the integrity of the problem, and that's the holistic nature of the problem. Then, so there are some trailblazers in the area of secure software development. So Microsoft did that. So we talked to them in Russia, and we try to identify what road they have already covered. And so there's a small disclaimer. So they admit that because what they publish, Microsoft, it's some kind of reverberation. So long. So that they got about 5-10 years ago. So now just they're moving forward, and so they publish certain things, and there are some instruments that they have. But the practice and the way they build it, delineate it, and what mistakes they have made, so then it's not available. It's not in public domain. So they play their cards very close to the chest. And so then developers for some exotic cases, for fashionable practices of project management, they do that too. And this is all can be found for each specific case can be available on needs basis. Then concerning these 2 points, these 2 phases. So because the requirements and design effort. So because the requirements on it to be at the basis of the development, but security requirements they are not existent, or they are related to some kind of basic primitive cases, and they do not see the big picture. For example, then so there is this maturity model of a logging system, maturity system, IT data management maturity. And then for the CM to occur, so it's desirable for all the objects and components of the IT system available. So they need to talk about themselves and do it properly. So there's best practices exist. And my most favorite case that we studied, so when this system was absent in the list, is the application of, and there was a presentation at the conference. I loved it. So then the network sniffer for applied protocol of the system that developed themselves. So they made a system, developed a system, but failed to the login system and to identify its conditions. So they added a monitoring system additive for the DPI. So they would do the protocol study. Then by the results of this research, they would figure out the condition of the system that they developed themselves. You see? It's a very interesting trait. Then, or the absence of those who do the analytics. So then the tracing of requirements is very important because they're interconnected, those requirements. So there was a server, so the server, they strengthened it, it became more powerful, then they balanced it, so the working servers, and then all logs got new addresses. So the sources, everything was balanced, so then this information went to logs. So, but they forgot to change the requirements. So then, tracing of requirements issue. It's there. It's very important, and is not. You cannot address it with the help of research and study of the product at the end of its development. It's too late. So, what are the useful methods, approaches, and instruments? So then Microsoft in the stack, SDL stack, we tried, we liked it, and we're trying just to apply it if it's possible, where it's possible. So then there is a poker planning, and so then there's a model of stride, a model of threats. There's confidentiality and availability expands this issue, enhances it, and then to widen your conscience with the developers, so you can always think of which components you need and where it occurs and how it all happens, and especially if you model the threats, if you work, so the architecture of the flow of data that occurs in the system, that would be good to do that as well. If it's scaled up in your company, this is great, and because you have the cross functionality, and so they will, and any developer will help you to identify the threats. Then the business side. So what are the business drivers and what are the stoppers? And so to make sure that this process is useful, may be used. So the first point, I always come up against it. So this is for generalized experience that I'm talking about. So first, return on investment. So we certainly need some tangible results. Return on investment. So business wants to understand. So to what extent? So if you invest more resources and time, then the return will be bigger. That's only, and I mean security-wise. It's not only money return, although it's important, but they're talking about it from the viewpoint of happiness of the developer and the calmness of the developer. So he's a quiet, happy time, and this is what they want. To what extent? So they need to respond to to the challenges, and so to what extent they can generate a serious crisis. And for example, so that Microsoft went through this some time ago, and so the same happened here with us. So that secure development cannot be done from scratch. So no one just will allow you to hire new people, to start a new product line, because those will be the legacy products, the same people, and they need to jam them into certain box, and so you cannot start from tabula rasa. It's impossible. But you have to work in the existing context, against the existing background. Then how to implement so security component into a big company, for example. So how to introduce it, how to embed it, this security component to make the entire system secure. And so there's lots of different products. So we need to streamline the products. Then we need to phase them in. The first phase most important. Then those that can wait. Then put them on the back burner, etc. And then eventually, so then approach. Then apply this approach. And then all the decision makers. So ask them to come out with their ideas or their viewpoints, or how it can be done, how it should be done. So how to streamline the products and the projects. And the first question I had when they just brought in their vision of the situation. So they had three respectable guys. They as a cross section. So the way they see their lives. And so they want this the way you immediately see it explains a lot. So this is number one, number two, number three, and that's how they view it. And then you can juxtapose it and compare and see how it works. Then what options do we have here? We could apply. So first, we need a certain idea need to be developed. A goal, so not from your point of the value at the market and the development. We'll talk about security, because this scale of security needs to be built independently, so technologically, and to what extent they will be vulnerable to attacks, etc. So we need just to build this line up from scratch, and then to predict where it may end. And then the initial data needs to be obtained, but they are raw. The data is raw, so this raw data will not be. It's not enough to sink your teeth into, and not enough to make any conclusions. And so then the model needs to be delineated separately in each specific case, and information that we have at the initial stage will not be sufficient and only tentative. And then what blocks the introduction of new research in the area of security? So for this, some argue it's expensive, some argue it's unpredictable, some argue it's impossible to meet the deadlines. We don't know how long it will take, and so some argue that there is an absence of the holistic nature of the research, that it will be properly done from A to Z, and then the probability that the research will not dovetail, for example, and so then there is another challenge that they may have to do the repetitive, iterative research, so meaning going back to square one. And that's why the owners of the system, so they certainly don't want to do that. They want to touch it because it's scary. And so they respond only once. There's only one. So then to do the research at the initial stage, so when it's not so much expensive. And so to do it. So for example, if they don't dovetail, so the classical problem when the research doesn't dovetail, and so developer hates the user hates the developer, so then the new things come up, and eventually so the new challenges generate, and then eventually so they start hating each other, so new problems pop up all the time, and so then the people who are involved in this research, and so we need to formulate that. And what about quality? So you cannot attain any good quality. So then the key demand is the sustainable process of continuous adaptive mode. So with managed control characteristics. So this adaptation should go on sustainably all the time, and to make sure that another research should be cheaper. So to design this process so that you can iterate research, and every time, every next iteration should be cheaper than the previous one, and so that would not provide for some radical changes in the essence of the product and would only complement what has been done earlier. And so just don't break it up, don't smash the system, just tinker with it, and then this iteration process won't be such an expensive, would not be a catastrophe every time they need to do some follow-up on that. And then eventually we came to the conclusion that, having realized the essence of the cycle of secure development, and then we need to have our body of knowledge of secure development, cryptography included. Yes, this is true. This is very challenging, because this is where we collect our know-how and how we work, and what's the essence of our research, and how it can be adapted, offered to the customer, and so our technical guys, so who do the development, and how just to put it all together, so this puzzle would eventually work out. And then another point, so taking point by point, because security is a teamwork, and so there was any product development so provides for the different roles. So everyone is responsible for his or her area, and so it's a team effort, and it doesn't work out that way. So there should be analysts who analyze research and so there should be managers who understand their area. So then everything will certainly fall into place. And the last thing, so when it's just common ground, common language, so we're looking for common language, and so when we talked about different cases, and so then vulnerabilities, weaknesses, and then replacement of imports, etc. All this story tells us that that it simplifies communication. You don't have to discuss why this vulnerability is dangerous in the software, and so we have to give this examples of hacking attacks, etc. And so there's no need, because now they're on the same page, understand what they mean, and so we don't have to do the ABC. Yeah. The legacy systems developing project to project, product to product, and it will, and then the customer will not get the feeling that they started from scratch. Because the new companies, they just design new things, open up new laws for themselves, discover new principles, and are happy to share it in the market. So they are afraid of such guys. This is all based on some knowledge, awareness of one's own weaknesses, and logically delineated. So we are involved in this, but I have grounds for optimism, and the business involvement and follow-up development and installation, application, and practice. And so I am positive about that and quite optimistic. What's good? What's in it for us? So it's a good initiative. So GOST, which is state standard for the development of FC tech. So it kind of motivates to do research, because before we had it, So they were, so then they were studying the vulnerabilities, but it was all segregated, it was random, but now it will become a specific lever, and that could be used to start competition, tenders, bids, development. Yeah, because then, for example, so a tender for the development is a good thing. So then, because the GOST standard, so because everyone is involved in the development of the means of contributing to the security of the system. And I talk to many developers, and all understand that because their products all have certain components of security embedded in it, depending on the importance of the information that they process. So Federal Security Service or the health system. And so, but this standard, this GOST standard, state standard, when it is released, and so I think that at the end of this year, beginning next year, so we expect it. But that will be a good lever to make sure that this works should be done properly in a logical, streamlined fashion, testing, research, study, and that could guarantee the integrity of the system at the development stage. And then identification of certain attacks, so the global monitoring system, and this system is important too, in order just to complete the circle, to make it integral, and that's how this is done, developed, and how it's operated, so the whole life cycle. And summing it all up, we can say that we need to build to destroy. And so then research, practical security, it's all it's developing very rapidly. So there are companies that specialize in it, and so they know how it works, and there are departments in big corporations. But the next challenge we're going to face is to make this effort in a more systemic, more streamlined, more sustainable, logical, so then bringing about the results searched for. And to stop talking who hates whom, but to start talking on so who can use, who can help whom, and to do this synergy canvas rather than this hatred plane.
And there are no options except, starting doing something. If you have some questions, I'm here. But yes, this is a complicated process. That's ungrateful activity, but quite interesting. I hope you enjoyed my story. So my view, and I would be ready to answer your questions privately. I'm around, and please approach me. I'll be happy to talk to you. Thank you.